Welcome to the Esri Developer Summit technical session, Building Apps with ArcGIS Runtime SDK for .NET, Part 1. My name is Mike Branscombe, and I'm the Product Engineering Lead for the SDK. I'll take you through the first part of this session, and later we'll be joined by my colleague Morten Nielsen, Software Engineering Lead for the SDK. This session, titled ArcGIS Runtime SDK for .NET, Building Apps, is split into two parts this year. This session, Part 1, will highlight the developer resources available to you and provide you with an introduction of building desktop and mobile apps. In Part 2, we'll take a deep dive into several important new features and capabilities that we introduced in the SDK over the last year since the previous Dev Summit. Let's proceed to Part 1. In this session, we will introduce the SDK with an overview. We'll explore the capabilities of the API, and we'll describe how you install and get started with the SDK. Then we'll take a look at building your first apps targeting desktop and mobile platforms. ArcGIS Runtime SDK for .NET enables you to add mapping and location analysis capabilities to applications that you build with .NET. The SDK enables you to target both desktop platforms and mobile devices. You can build applications for Android, iOS, and Windows. A consistent common API design and implementation across the platforms enables you to write shared code. Writing native applications with .NET enables you to match the user interface and user experience conventions of your target platforms. You can also access native device capabilities, such as Bluetooth GPS and sensors. You can build applications that are connected to the ArcGIS system with ArcGIS Online and ArcGIS Enterprise. You can also build applications that are occasionally or completely disconnected from the network, with support for local maps and data. The SDK provides a number of resources to enhance your developer productivity. Let's explore the capabilities. When planning to build an application with ArcGIS Runtime, it's important to explore the capabilities of the SDK and the API to build your understanding of the full range of functionality available to you. We create multiple resources to help you do this, including the ArcGIS developer site containing the guide and tutorials, sample code, open source apps, demo apps from the .NET team. And if you can't find the answer to your question, then you can ask the Esri community. Let's take a look at a demo of exploring the capabilities of the SDK. To explore the capabilities of the API, we're going to start with the ArcGIS developer site and navigate to the documentation for ArcGIS Runtime API for .NET. The overview topic here provides a great starting point for your journey in exploring the capabilities of the API. Let's follow the step here to learn about key features. The key features topic provides a high-level description of the range of functionality within the API. Starting out with maps, it progressively introduces fundamental concepts from base map layers and operational data layers to offline workflows. Other functionalities in this topic follow the same pattern, from 3D scenes to analysis and data models such as utility networks. After reading the high-level points, you can choose to explore a sample, follow a tutorial, or read more in the guide. Here, let's take a look at the sample. Within the developer site still, I can view information about how this sample was implemented, and I can view a presentation of the source code. If I tap this link, that will take me to the public GitHub repo for the sample code. Or if I tap this link, it will take me to the Microsoft Store, where I can download and install a compiled version of the sample viewer. Switching to the store, we can see the ability to download the sample viewer here. So this is a pre-compiled sample viewer allowing you to interactively explore the samples. It can be launched via the Start menu on your machine, and you can know that it will be automatically updated when we publish an update with each release. Now I've already installed the sample viewer from the store, and here I am looking at the generate offline map sample. Now I've actually already gone ahead and taken this map offline, and we can see that the base map has been downloaded within the rectangular extent defined by that red envelope, and any features intersecting that extent have also been taken offline. So the samples within the sample viewer are interactive. I can also read in the description tab more about how this sample was implemented, including taking a look at the relevant API classes. And then again, I can see a presentation of the source code here. Now the samples are purposefully designed to demonstrate small, discrete pieces of functionality. To see the API used in a complete workflow, you should look at the open source apps. Returning to the ArcGIS developer site and the documentation for ArcGIS Runtime API for .NET, over on the right-hand side, we'll navigate to open source applications. And we can see here for the .NET API, there are 3 open source applications available: data collection, indoor routing, and maps app. We're interested in data collection here. The data collection open source app is one of a number of open source app projects that we make available on GitHub for you to access the source code. The documentation provides information about how the application was implemented. So it provides information on the data that's used, provides information on the features that are implemented in this open source app. And crucially, it tells you how you can make this app yours, how you can tailor it for your situation. The section at the top tells us the platforms and APIs with which this open source app has been implemented. So it's available for the ArcGIS Runtime SDKs for Android, for iOS, and for .NET. We're interested in the .NET application here on Windows. Switching to the open source application, we can see the scenario for this is a tree survey in the city of Portland. The application shows a number of interesting UI patterns and valuable UI elements that you may be able to use in your application. There's a sign-in workflow to authenticate with the ArcGIS platform. There's the ability to work both offline and online, so download the map and data, perform edits and interrogate the data locally while disconnected from the network, and then once connected, synchronize those edits back with the service. A number of other user interface elements here that may be valuable to you. Return to the default extent of the map, zoom in and zoom out navigation controls, integration with location display centering on your location if you have a location provider configured. Other elements here include a legend, retrieving the legend information from the layers within the map, a table of content, allowing you to interactively enable and disable the visibility of layers within the map. If we are to click on one of the features within the map, any features within the tolerance have been selected and identified, and we can explore the attributes of those. So drilling down into one of the multiple features that have been returned, we can see there are 4 results. We can step through each result. You can also see that the presentation of the attributes of this feature includes returning the related records. So we can see one related record, and we can add additional inspections to this tree, which are handled as related records within the geodatabase. As well as interrogating existing features, this application shows a workflow for adding a new feature. So in the center of the map, we can see a pushpin, and the workflow involves dragging the map until the pushpin is placed where we want to add a new feature, and then saving and entering the attributes for that new feature. If we switch to the Visual Studio project for this, we can see that there's a number of Windows project heads for this solution. We were just looking at the WPF.NET Core project. There's also WPF.NET Framework and a Universal Windows Platform project as well. We can see that this application shares code across these platforms. And within this shared project, we can see both models and Viewmodel folders. this tells you that the application has been implemented following the MBVM pattern. So we're showing development patterns within the open source applications that you can take and use in your own development. There are two other resources I'd like to highlight. The first of these is the .NET Team Demos repo, where we publish self-contained demo apps that we've built for past and present conferences that showcase a variety of workflows. Here there's a symbol editor application which shows you using mobile and web styles and creating and editing vector symbol layers. The other resource you will find invaluable as you get started in your development is GIS NET, the Esri community. Here you can ask questions and get answers from fellow users and Esri staff. And also, as your knowledge grows, you can help out other users by answering their questions and sharing information that you found out. Now we've seen how we can explore the capabilities of the API and of the SDK, let's move on to install and get started. As we've learned so far, ArcGIS Runtime SDK for .NET enables you to build applications for multiple platforms. To set up your environment for development and be able to explore and build apps for all of these, you will need to ensure you install the following Visual Studio workloads. Workload.NET Desktop Development enables you to build apps for WPF targeting either .NET Framework or .NET Core. Workload Universal Windows Platform Development enables you to build UWP apps for Windows 10. Workload Mobile Development with .NET enables you to build apps for Android and iOS with Xamarin, including a cross-platform UI framework with Xamarin Forms. Once your environment is set up, you reference the ArcGIS Runtime API for .NET via Nougat packages. We upload these packages to nougat.org on the day that we release each new version of the API. You can browse to these from within Visual Studio and add them to your new or existing projects. There are packages for each of the UI application platforms that we support: Windows Presentation Foundation, or WPF, Universal Windows Platform, or UWP, Xamarin Android, Xamarin iOS, and Xamarin Forms, with Android, iOS, and UWP. We also publish Nougat packages containing additional UI controls. There's a toolkit containing a number of common controls that you'll use in mapping and location analysis applications. There's an augmented reality toolkit for implementing augmented reality apps on Android and iOS. And there are additional capabilities available in the hydrography Nougat package and local services Nougat package. ArcGIS Runtime SDK for .NET also includes a Visual Studio extension for Visual Studio on Windows. This can be installed directly in Visual Studio from the online Visual Studio Marketplace via the Manage Extensions dialog. It provides application project templates to give you a quick start for new applications and to make it easy to build prototypes. If your development is primarily offline and Nougat.org may not be accessible to you, we also provide a Visual Studio extension that includes both project templates and Nougat packages. This can be downloaded from the ArcGIS developers site. Now that we've seen how you install and get started with the SDK, let's move on to building desktop apps. When you want to create a new desktop application for Windows, the first decision you make is which application platform to use. ArcGIS Runtime SDK for .NET supports two of the application platforms available for building desktop apps on Windows: WPF and UWP. Using the WPF application platform allows you to build Windows desktop apps for Windows 10 and Windows 8.1. WPF development with ArcGIS Runtime supports multiple .NET runtimes, the classic .NET Framework 4.x series. It also supports targeting .NET Core 3.1. And note this is currently the default for the WPF project template included with the SDK. It's easy to update your .NET Core 3.1 projects to support the most recent version of .NET Core, which is .NET 5. If you're still developing with Windows Forms, it's possible to use the ArcGIS Runtime controls within the Windows Forms Integration Element Host control. This enables you to begin upgrading your application with WPF. Note though that with WPF there are some limitations too. For example, it doesn't have first-class support for high DPI and touch, although both are possible to achieve. Targeting the UWP application platform allows you to build apps with the modern user experience you've come to expect on Windows 10. Note that with UWP, you don't necessarily have the same level of full system access you do with other frameworks. For example, devices, full disk access, or perhaps specific authentication workflows may be more challenging. We're also looking ahead to the future of Windows desktop development and the direction of these application platforms. We'll talk more about this in part 2 and encourage you to attend to the live ArcGIS Runtime Road Ahead session. There are some additional components you may consider using in your development. The first is the toolkit for ArcGIS Runtime SDK for .NET. The toolkit contains controls commonly used when building mapping and location analysis apps. It's provided as a Nougat package on nougat.org, but it's also open source, which means you can take the source code, modify, and extend the controls to fit your requirements. The toolkit isn't just available when building desktop apps on Windows, it also includes the same controls on Xamarin Android, and Xamarin iOS, and Xamarin Forms. Additionally, if you're targeting .NET Framework or .NET Core on Windows Desktop, you can use the ArcGIS Runtime Local Server component. This provides REST-based services running within the context of the local machine. Local geoprocessing services enable advanced spatial analysis and data manipulation workflows with ArcGIS Runtime. Developers and GIS professionals create geoprocessing tools in ArcGIS Pro with Model Builder or Python and publish those as geoprocessing packages for use with the local server. Now let's take a look at a demonstration of building our first desktop app. In this demonstration, we're going to look at building desktop apps with ArcGIS Runtime SDK for .NET. We're in Visual Studio here, looking at the Create New Project dialog. We're going to take advantage of one of the project templates that's included with the Visual Studio extension. We want to build a desktop application for Windows, and then we're going to filter by the ArcGIS project type, and that takes us straight to one of the templates that we want to use here. The ArcGIS Runtime App template, and this is targeting WPF on .NET Core. Give the application a name, and then we'll let Visual Studio extract the project template. And we can see in the Solution Explorer here, Visual Studio is resolving the dependencies, and it's resolved the reference to the API. We'll just build the solution to make sure that everything is good. We can see that the build succeeded. So let's run the application as it is right now and see what we get out of the box. So we've got a window. The window is filled with the map view control. You can see there's a base map layer in the map view control here. There's an attribution bar, so that helps keep us compliant with the attribution requirements of the map content. We can see there's a developer watermark here as well, so I'm running developer mode at the moment, and it reminds us that we need to think about licensing when we want to deploy our application. Let's take a look at how the application's put together. We've got a main window XAML file here. If we take a look at the XAML, we can see the definition for the map view, and we can see the map property is actually set by binding to the map property in map view model. We can see the definition, creating an instance of the map view model here in our window resources. So we can see that within our XAML, we're taking advantage of binding to a map view model, so we're introducing the MVVM design pattern in this project template. Let's take a look at our map view model and see what's going on there. Well, we can see that a new map object is being created, and it's using the base map create streets vector method here. So what if I want to change the base map to something else? Well, let's use one of the new base map styles, and I really like the ArcGIS Nova style. Let's run the application, and we can see that the map view is now actually blank. We can see that the Powered by Esri logo is here, so the map view control is still within the window, but no content loaded. So how can we find out more about what just happened? Well, what we're going to do is move our creation of the map to an initialize method. So we'll add an initialize method here, and then that defines or adds a handler for the map load status changed event. So let's add an implementation for the event handler here. We need to just add a namespace for systems diagnostics, where we're going to write out the information about the load status changed event, and then if the load status has ever failed to load, we're going to write out the load error message. And finally, we just need to call that initialize method from our map view model constructor here. So this time, we're going to use the ArcGIS Nova base map style, but we're going to handle any load status changed events that fire, and if there's any errors, we're going to write those out to the output window. So we can see that load status change fired from not loaded to loading, and then went from loading to fail to load. And there was actually a load error that says token required. So this is telling us that this new base map style is part of one of the base maps that require either an API key or an ArcGIS identity. So let's take a look at the application class here. And this is a good place to set up the API key or perhaps handle authentication. We can see that within the application startup method that's included with the project template, there's some information here about authentication and use of the Esri location services, requiring either an ArcGIS identity or an API key. There's also information about licensing, so it tells us about production, deployment of applications, requires licensing. And there's a couple of links there for more information. What we're going to do here is just set the API key directly in the application. And as an ArcGIS developer, I'm going to go out to my developer dashboard here, copy my Dev Summit 2021 API key, and then go back to Visual Studio and just paste that in there. So that's all I need to do to access that API key secured base map. This time when I run the application, we're going to see that the map loads, the base map loads, and we can see that the load status changed, went from not loaded to loading, and then loading to loaded. And we can see that nice ArcGIS Nova base map style there. So what we've just seen here is using one of the project templates that's included with ArcGIS Runtime SDK for .NET. It was the project template for WPF on .NET Core. We looked at the definition for the UI in XAML. We looked at binding the map property for the map view control to a map property within our map view model. So an introduction of the MVVM design pattern here. And then we looked at changing the base map style and trying to diagnose potential issues that come up through use of the API. So using the API to handle any load status changed events that were firing and then report those load errors.
So Mike just showed how to build a desktop app using the Runtime SDK, but we can also use the same SDK to build mobile apps for iOS and Android. And we do this by using the Xamarin technology. And Xamarin allows us to build .NET apps and the same .NET code to actually deploy them and run them on mobile devices as well. And so this is a sort of a re-implementation of .NET that can run on these devices, but it provides all the same base libraries like system.math and system.io file reads and so on and so forth. So you can use a lot of your same business logic across different platforms. In addition to that, you also get these called bindings that takes all the native Android and iOS APIs and expose them to C#. So you can literally take Android and iOS code written in Java or Kotlin or Objective-C and sort of translate them to C# and have the exact same code run. So any APIs that are available natively on the platform, you can call directly from C#. Of course, this code won't be cross-platform, it will be specific to that platform, but it gives you the ability of both building generic cross-platform .NET code and also target the device specifically how you want it. And you can do this just by using Visual Studio, or you can also use Visual Studio from Mac and do all this on a Mac. And it's a really cool way to share some of your code and reuse your skills, but also deploy to multiple kind of devices. So when we talk about building Xamarin apps, we would sometimes talk about building a native app, which is a Forms app. And they're all native in this sense, but when we generally refer to it, we're talking about a native app is an app that uses a lot of the native APIs and are built just for that platform, typically around the UI. That doesn't mean you can't create .NET code that can be shared, but when you, for instance, target Android, you would use the XML layout, use activities and intents, and write that code as if it was for an Android app, and you use a different code for iOS to do their user UI kits, storyboards, and so on to print your UI. Similar again, if you target UWP, you'd use Windows XAML, pages, framework elements, and those sort of things. But again, your business logic, again, can be shared, but the UI presentation would be a complete separate implementation for each platform. If you build a Forms app, you get an abstraction across all these different UI frameworks, and you can just build your UI as well in one place and then reuse them and deploy them to all of them. And the nice thing is that when you build a text block control in Xamarin Forms, it will automatically render to the native type of text block or button or whatever it might be and get that native look and feel. And while there is ways to style them so they look the same across all the different devices, by default you get like the default look of the platform. You can still access your native APIs to really tailor your app, but it's a really neat way to just reuse your app and quickly get an app running on multiple different platforms at the same time. With respect to sharing code, there's many ways to share code. The typical way to do sharing code today is you kind of link your file in to multiple projects, but there's an easier way to do that by using shared projects. So shared projects are sort of a group of files that you want to have compiled into each project that you target. So you would create a shared project, put all the common code in there, and then you would reference it into each project. And that means that whole chunk of files would all be compiled into each app. Makes it really easy to provide platform-specific code, but you could use something like directives, where say, if I'm on iOS, then I want to run this code. If I'm on Android, I want to run this code. And you'll get full access to each platform there because the shared project isn't a compilation itself. It's just sort of referenced into each project and will be compiled in the context of the project that they're referenced by. Another approach is the .NET Standard Library, and that's just a single assembly that can run on all. And so the .NET Standard defines a set of .NET APIs you can call. So the native iOS and Android APIs will not be in the .NET Standard because they're native and specific for that platform. But it's a really neat way to force integrate a good abstraction between platform and UI code and just business logic. And it also provides you just a single assembly that can run on all these different platforms at the same time. If you do need to write specific platform code, like you want to hit the local Bluetooth APIs, for instance, then you might have to do something else there. And one way to do this is that each project that targets a specific platform would sort of implement an interface that, for instance, the user up and creates a Bluetooth device and passes that into your standard library through dependency injection. Another way to do it is your .NET Standard library can be set up to do what's called multi-targeting, where it not only compiles for .NET Standard, but can also compile for all the platforms you want to compile. And you then can still do the compile directions in your .NET Standard library and build it as a .NET Standard, but you can have implementations underneath that targets the platform specifically. In fact, this is how we build the runtime as well, where we actually compile it for all the platforms, but put it in a .NET Standard package, and then there's platform-specific code based on which platform you're going to deploy the assembly to. But instead of just talking about it, why don't we start with just build an app? So let's first start by creating a new project. And here I have the ArcGIS category picked, and you'll see this. There are several Xamarin Forms projects like Xamarin Android, Xamarin iOS. We have the Xamarin Forms Standard and shared projects that I was also mentioning you can do the different ways. But instead of starting with these project templates that already sets everything up for us, I'm just going to start with a completely blank Xamarin Forms project template. So I have various starting layouts I can pick from here. I'm just going to start with the most basic blank one and pick all the platforms that support it. And here we have my project now all set up. The first thing I do is to set up a few things to get it ready for supporting the Runtime SDK. So the very first thing is, let's just go to our Nougat package manager. I'm going to right click and say Manage Nougat Packages. And we're just going to make sure that we have the latest version 5 installed that is currently required. So I'm going to upgrade that just to the latest. And let's also install the Esri Runtime. So here we're just going to pick the one that actually just says Xamarin Forms. That will in turn also reference the dependent package we need. And we really only need to add this to this first project. And so while we do this, you'll see there is 4 projects. And the first one up here is the .NET Standard project that has all my app logic. I have my main page, my application page, and then I have 3 project heads here. One for each platform I wanted to deploy to. There's Android, iOS, and UWP. And this is where you define stuff like app identity, their icons for the platform, which sort of permissions, can it access Bluetooth, location, those kind of things you're configuring in these projects. Okay, because we are requiring to run on Xamarin Forms 5, I need to make sure that my Android project is targeting at least version 10. And for UWP, we also need to make sure that our minimum target is a version that is supported by the runtime. I'm going to pick here 17.134. Okay, so now that we're set up, we can go into our main page and we can then define our map. So here's some default XAML that we have. I'm just going to get rid of all of this and put my new own grid. First thing I'll do is I'll register the Esri namespace. It actually comes up as the first option right here. And now I can say Esri map view. Let's give it a name. And maybe we'll add a little bit of text. You notice here it's called label, not a text block. That's one of the differences you sometimes see in Xamarin Forms. Some things are named slightly different. The way we align things are also different. Maybe you want to add a little bit of extra margin here at the top. And then I need to go into my application and I'm going to have my map view, map equals new map. Let's pick the same one that Mike used earlier. And if you recall, that did require us to set an API key. So similarly, I'll go in here in the application startup and I'll just define my API key. And so you see that a lot of the code I'm writing here is identical to what we were writing in the desktop app, because the APIs are almost completely identical for the most part. So this should actually be it. With a little luck, I have set, you can see the UWP project is currently in bold. That means it's set as a startup project. So I should just be able to run this app and view my map. There's my app, it's launching, and we have the exact same map here running as a Windows Universal app, but in a Xamarin Forms context. But that's all interesting. But what do we want to run on a mobile device? Well, really all I need to do is right-click the project I want to run, set it as a startup project, and it will now in the drop-down I'll be able to pick what I want to run it on. Right now I have this phone currently plugged into my computer, so this will show, but I can also create new Android emulators to run on if I want to do that. So here I'm going to start the project, and we'll start building. And my app is now launching on my phone. And with a little luck, we should see the exact same app without any changes now running on Android as well. There we go. Pretty cool. So that's Android. Let's try and see if we can deploy to iOS as well. So with iOS, we do need a few things. First, we need an Apple account. I have already configured that in my options in here. If I go into Xamarin, iOS, Apple accounts, I have set up my account here. Another thing to go and check is that you are actually set up to sign this application. So I'll go into my bundled signing options. I'll just set it to manual, and here actually pick my developer account. I'll just set it like that. Okay. And the other thing is I want to be able to deploy to a device. And the first thing I do is, in this case, I'm connected to a Mac. It always says paired to a Mac, but typically you would go in here, add a Mac, and connect to a build host that actually is going to compile. And that is where I currently have an iPhone connected to. So in my dropdown now, it'll actually show all the different simulators that are available on that Mac machine, as well as the phone I currently have plugged into it. So I'm just going to pick the phone to deploy straight to it and just try and run the app. And here's my app running now on iPhone as well. So you'll see we actually get very similar applications running on both devices, which is pretty cool. And they look identical and can run on all these different platforms. Okay, so that was a quick little demo of just how to get started with your very first Xamarin app. There's quite a few things I didn't just have time to show, but I do want to point out that are some cool features you can get with Xamarin. One of them is Hot Reload. Hot Reload is this feature where you can actually sit while the app is running on your device and modify your SAML. So you can move the margin a little bit up, or move the device a little bit to the right, or change alignment, change font sizes, and kind of get this iterative experience. Instead of using a designer that doesn't actually fully execute your code, you can actually have a running app where you can on the fly modify your SAML and have the app instantly update on the device. And it can really give really quick turnaround to getting your app to look just the way you want to make it look. There's another library called Xamarin Essentials that is a good cross-platform API that provides a lot of benefits for storing, for instance, storing various settings, for accessing device sensors, for accessing permissions. So there's a whole set of range of APIs that are sort of been abstracted away, so you don't have to write these cross-platform APIs. So this is a .NET Standard library, but under the covers, it's multi-targeting, as we talked about earlier, where it actually writes platform-specific code for each of them. But you don't have to worry about this because you just reference it in this .NET Standard context. Another thing I would really recommend is, and I didn't actually do this here, but Mike did, was using the Viewmodel Pattern. And that makes it really, really easy to get that great abstraction between your platform-specific and UI code from non-UI code. And that especially becomes important when you start building apps that might also have to run on desktop, where you have a completely different UI model, and in WPF app, for instance. So really get that abstraction is a really good way to do it. It also forces you into getting a very clean separation, which I really like about it. And it can be very easy to write an app just for a single platform first and then later add it, but we found that's actually a lot trickier than thinking about cross-platform from the get-go. If you're building an app, you know you're going to cross-platform. Like, I would suggest actually building them in tandem at the same time. And then test on all devices. All the devices are a little bit different. Some of the screens have little corners or little cutouts for the camera that you have to take account for. Some devices run faster than others. There's different GPUs, different CPUs, different memory requirements. So it's pretty important to actually test on real devices. Emulators are great. But in the end of the day, running on real hardware and a variety of them can be really important. Also, like considering different form factors like desktop with the mouse interaction if you do UWP as well, but also tablet versus phone can actually create some very different UIs you might want to optimize for each of those UIs. And then another thing that's really cool is if you don't have a Mac, you can actually plug your iPhone straight into your PC and deploy straight to it. It only works with Forms. You can't do a native UI app. It has to be a Xamarin Forms app. But it allows you to just deploy straight up without having to go through the Mac. And it can be a little bit faster to iterate in that way as well. In the end, before you actually deploy to the Apple Store, you do have to compile on a Mac to be a full-on compilation. But it can be a really cool tool for just getting some stuff going without requiring to actually get a Mac device set up as a build host.
In this session, you've seen how you can explore the capabilities of the API and the SDK and how you can install and get started in your development. We've looked at how you can use the SDK to build apps for Android, iOS, and Windows, and how you can share your code across the applications for these platforms. And we provided an overview of the SDK resources that we create for you to support your development. The Visual Studio extension with project templates, the ArcGIS developer site with guide and API reference documentation, samples, open source apps, demos, and of course GIS NET, the Esri community. This session was part 1, in which we covered an introduction to building desktop and mobile apps. Remember to keep an eye out for part 2 for a deep dive into new features released since Dev Summit 2020. Thank you very much for listening to this session. We hope you found it valuable. Hi folks, I hope you enjoyed the session. My colleague Morten and I are now here to help answer any questions that you might have following the session. Feel free to use the Q&A chat window to ask us any questions. And we'll try to answer those in the time we have available now. If there's any questions we can't answer in the time we have, then feel free to head over to the Ask Our Experts area or reach out to us in the Esri community. So we did have some questions during the session, which we'll dive into now. So the one question that we had is a license required to program using ArcGIS Runtime SDK for .NET? And technically, there isn't a license required to program with ArcGIS Runtime SDK for .NET. You can just reference the Nougat packages and develop against the API directly, referencing a variety of data sources. You will get the best experience and access to online base maps and other services such as geocoding if you sign up for a free developer subscription, and that gives you access to create and manage API keys to access resources. Beyond the free developer subscription, there's a number of paid plans that you can upgrade to that provide you with additional capabilities.
We have a second question about if you have multiple mobile applications and you want to share data, for instance, a raster package, like, is that possible? And for Android and iOS, there's slightly different ways to do that. On iOS, you would typically configure what's called an app group in your developer account. And if those two apps are part of the same app group, they can actually share data that way. So that's totally doable. I'll share some links in the reply to that. For Android, as long as you can read out, you give the application access to read outside your application folder, it's possible for multiple apps to actually read from the same folder, so as long as they have been given access to it. Something similar applies with UWP. There's a way to have what's called a publisher cache. So if you're the same publisher for all your apps, then there's also a way for these apps to read data and share them. And of course, if you're building a standard desktop app, you don't have these sort of restrictions and can read files anywhere. But I'll share some links to some documentation in the reply as well. So that's totally doable.
Okay, we had another question about sharing the GitHub path. We provided a link there, which is the search for the public Esri organization on GitHub that will let you access a variety of .NET repos, including our samples, toolkit, demos repo, and the open source apps. Somebody noted that there was appeared to be a spelling mistake in the link to the toolkit. Unfortunately, that was just the formatting on the slide there. It was the text was formatted as a URL, and that hid the lower part of the G. So it is ArcGIS toolkit.net for the correct link there. Right, we've got another question. What's the difference between ArcGIS Runtime SDK and ArcGIS API for JavaScript? Morten, do you want to take this, or shall
I? Sure, I can take that. Well, look, the most obvious difference, of course, is like one is a JavaScript API for doing browser apps. Where the mobile SDK is completely native, it runs with native code much closer to the metal. We would use direct graphics cards. It will be able to use device resources like your built-in GPS and sensors. And you can do some of that with JavaScript as well. But we get it's optimized for mobile and desktop and allows you to give these kind of cross-platform APIs. And the set of capabilities is also different. We were able to work with mobile map packages and direct rasteries and stuff. So there's more capabilities in the runtime. We're working with offline data and syncing and working directly with those sort of data formats like local routing data sets. And so they're sort of like different use cases, I would say. Like the JavaScript is more geared towards distributing on the web and through browser apps. And the runtime is more geared towards having an executable on your system or as a mobile app. So that's sort of the main difference. You can write quite a lot of different languages for the runtime as well. But if you want to do .NET, you can use C# and VB.NET, or Qt, you can use those languages, or iOS and Android, the Kotlin and JavaScript and so on. I hope that covers it. There's another question here about can the ArcGIS Runtime SDK be used to deploy as a web application rather than a desktop application using .NET Core 3.1? It's a common question we get. The short answer is no. You can't use the runtime as a web application. Correctly, .NET Core, you can build web applications with, and you can build cross-platform web applications. We do not support that. .NET Core is Windows only. And license-wise, it's for desktop apps, not web applications. So it's not something we at this point support for running. It's meant to run as an app on your desktop machine and not as a web app.
Okay, we had another question here. We've had issues getting the OAuth workflow with enterprise credentials to work on Androids. We get a white screen. So we get the prompt, does .NET SDK support OAuth login with enterprise credentials? That workflow should work, and this might be a question that we need to do some additional follow-up on. We're aware of some issues with IWA authentication with Androids. Unfortunately, some of those workflows were impacted by changes to the underlying Xamarin Android HTTP handlers. So there are some workflows which previously worked with, I suppose, enterprise or IWA authentication, which no longer work. But the OAuth enterprise credential workflow, I believe, should work. So I'll reach out to you, or I'll share my email address in a reply to that question, and you can get in contact and we can follow up.
Another one here is the API key seems to be required for new online base maps. Does this become a requirement to access all online base maps now? And also, can the API key be used to access secured services hosted via your ArcGIS Online or ArcGIS Server services? Mike, you want to take that one?
Sure. So the API key can be used to access secured services on ArcGIS Online, currently not ArcGIS Server services. But I suppose that's a workflow that's under evaluation. There's actually two possible workflows. There is the API key or an ArcGIS identity. So you can authenticate with an ArcGIS identity and have the same access as an API key.
Sort of along the same lines, there's another question is, what is an API key?
Were you just reading the question, or were you going to answer it, or shall I?
Oh, you're going so well. Continue.
Okay, so I suppose an API key, it's effectively a token that will be sent with requests and allows you to authenticate your application for access to content and services. As a developer, you can use your developer subscription. You can sign in to your developer dashboard, and you can manage those API keys. So you can create new API keys, you can revoke API keys, you can limit the scope of API keys to particular sets of services. And it's essentially an alternative workflow. It's an industry standard workflow, but it's an alternative workflow to using an ArcGIS identity to authenticate for content, access to content and services. So we wanted to provide additional capabilities to you as developers. There's a question here that all of the 10.2x to 100x migration documentation appears to have gone or have broken links. Do you have any links we can use? We did roll out a brand new developer experience and documentation site earlier this year, at the end of January. As part of that new developer experience site, we're still migrating some of the content over. So the topic about migrating from 10.2x to 100x is not available in the live documentation, but if you sign into the developer site and go to the downloads section, you can access the guides for previous versions. So you can access the guide, downloadable guide as a PDF for version 100.9, and you'll find the topic within that PDF.
There's another question like, is the field maps built using .NET SDK native or Xamarin? So the field maps app are built by the app team, and they're not using either of these. They're using the runtime, but they're using the Android and iOS SDKs to build those. They don't use the .NET SDK or Xamarin to do that. So I wish they would, but they have already had that experience and had already gone down that.
There's a question here about a desktop application that uses ArcGIS, ArcObjects SDK for .NET, where there's extensive spatial editing in local file geodatabases. Are there any limitations to editing local file geodatabases using ArcGIS Runtime? Does it require local server? So to answer that, there is no direct support via the ArcGIS Runtime API for file geodatabases. That's the .gdb extension. So to access and edit data within a file geodatabase, you'd need to use the local server component. So the second part of that question, the answer is yes, it does require local server. The alternative workflow there is to use the mobile geodatabase. And those can be created in read-only workflows within a mobile map package in ArcGIS Pro, or in a read-write workflow. They can be downloaded from a sync-enabled feature service and then edited and synchronized. And then on the roadmap is additional support within ArcGIS Pro and ArcGIS Runtime for creating ad hoc creation of those mobile geodatabases, editing those and sharing those between Pro and Runtime.
And there was just a question added that's sort of the same along lines. Is it possible to use local data like Mpks instead of web services on desktop applications?
Yeah, so it is possible to use local data. The example given there, .mpk, is a map package from ArcMap. We supported the ArcMap map packages up to and including version 100.9 with the local server component. The local server version 100.10 and onwards supports the ArcGIS Pro map packages, which have a .mpkx extension. But there are also many more local data formats that are available with ArcGIS Runtime. So there are mobile map packages, mobile scene packages, which is the 3D equivalent of a mobile map package. And then there are a variety of data formats that are supported as well. So geopackage, shapefile, a variety of raster formats.
So another question here about, we have some apps we have built for ArcGIS Runtime for Qt/C++. Any recommendations or tips for migrating to ArcGIS Runtime.NET Xamarin? I would say like there's not like an easy way to migrate, like it would be a complete rewrite. However, we are very much in sync between all the different runtime APIs and the API design. So we have the same concept of a map and a map view. The method names will be identical or almost identical. Sometimes we tweak the casing. We might change the type slightly to match the, in our case, the .NET specific types. And so it looks more and feels like a .NET SDK. But anything you already built in Qt should feel very familiar with respect to runtime. Of course, there's the underlying framework, like how you code against .NET and use those types will be different from Qt and C++. But for understanding, if you already have familiarity with the runtime itself, that should more or less just port over in the same workflows you have there. But of course, you have a completely different UI framework. The language is different. So there'll be a lot of work involved in that.
Next question there, is it permitted to use the Runtime SDK within a Windows service when it runs on a desktop machine, when it runs on a server OS? So the permitted use of ArcGIS Runtime is within applications. It's not allowed to be used as a Windows service or a web service which does processing, which could be, I suppose, used by multiple applications.
Right. So we have time for one more. We're almost running out.
So the next question is about licensing. What licensing is required for users that just view a map and not edit or change data? So for just viewing a map with content that comes from the ArcGIS system, the licensing can be as low as a light license, which you can access with your developer subscription for free. And then the licensing increases beyond that through basic, standard, and advanced. So it's quite likely that you'll find for just viewing a map with content from the ArcGIS system that the licensing is a light license, which would be free.
All right. I think we're out of time. We have a few more questions. We'll try and see if we can reply in here or come over in the Ask the Experts channel. And we can also help you out over there. Thank you again for joining. We'll be doing a part 2. We're going into more of what's new and some more advanced topics in the next part in about 15 minutes. So we'll see you all there and hope you enjoyed this. Thank you.